All right, so we're going to build on what we talked about last time, except this section focuses on matrices. So this is when you're first introduced to matrices. We already started talking about it. Now, some quick theory is videos, a chance to check out. But one quick thing, a matrix is considered square only if the numbers in rows are the same. So if it's n by n, that is a square matrix, meaning 2 by 2, 3 by 3, 4 by 4. Those are square. Ready? A matrix derived from a system of linear equations, which is what we did last time. So if you have a system and you change that system of equations into a matrix, you put the constants on the set. So you have a little dashed line over here. You'd have all constants or whatever. Here you have. Okay, so this represents equation 1, 2, and although the way I wrote it in echelon form. So when it's in this form, it's already small 4. Obviously, you need to get to this point, but just remember, numbers over here, equations on this side, coefficients. So yeah, matrix in row echelon form, reduced echelon form. So we just had right now. One, the leading, it's in the main diagonal. So you have one down the diagonal. So right? So just remember what that looks like. That's called, it's not a huge deal, but that's what that means. Also remember that dimensions are always row by column. Okay, forget row by column. And the book says, I think n by m. So this has 1, 2, 3, 4, 5 columns and a single row. The dimension for number 5 simply 1 by 5. One row by 5 columns. And over here you have 1, 2, 3 rows, right? So the dimension be 3 rows by 4 columns. Is that clear how I got these numbers? The dimensions. Is that okay? Right. Soon ask you about dimension. We did mention it last time. Check this one out. It's a square matrix. So it's 3 rows by 3 columns. This would be considered square. Here they want you to change a matrix or a system of equations into an augmented matrix. Or an augmented matrix. Basically means your x is down the first row. So 4x and 1x, that means 4. 1. Just the coefficients, right? Negative 1. So here, on this question, all they want you to do is, which we did last time, but here they're actually going to actually going to make you do it. So right hand side is the constants, 7 and 4. And the left hand side is the coefficient part. That makes sense. Okay, so not too bad, right? Assuming comment means super easy, you guys are all. All right, so here, notice that the system looks a little strange. It's the same thing, but it's a little more complicated. There's a missing C. But if any variable is missing, just remember it's going to be a 0. Okay? All you have to do is questions just make sure the X is on the first column, Y is in the second, and Z is in the last column. So down the first row column, 7. Next one would be -1, -9. It says the X, Y, and Z. 4, 1, 0, 4, -1. Right? So not too bad, right? Here they're asking you not to perform any row operations. So meaning don't solve it. And I'm not going to make you do row operations. I'm going to have you use a solver or your calculator. That's it. But make sure you're able to go back and forth, right? So if you have a matrix, you have to remember that this first row is X and 4X, right? This row is the base minus 7. And then the constants, of course. If they are not in order, when you're the other. Well, if it's in this form, you're good. But if, let's say, the X's are switched to the Y's or whatever, just put them in order. X's first, Y's, Z's, etc. And then just convert it to your matrix. Okay. So here they want you to convert again. To use X, Y, Z, and W if needed. I gotta put that here. And number 13, what they want you to do. Oh, I see. Here I would just use the X. So for 13, you could use back substitution. See how it says use this. You see how they give you if you convert this to an system equations, you're gonna X minus. Let's go and do this. So use back substitution. To solve this guy. Okay. So if you change them to equations, you're going to get x minus y plus 2z equal to 4. There's no x's here, so you're going to get y minus z equal to 2. And then the last row, z equals to -2. So plug in the -2 there. All right, so you're going to get, so if you use equation 2, y minus -2 for equation 2, let me write that. Equation 2, that becomes y plus 2, which means that 0. Okay. So that's what back substitution means. You start with this one, plug it in here, solve for y, and plug those two in here. So now that I know that z is -2 and 0, go to the first one. Plug in your 0 plus your -2. This is equation. So we're going to get x minus 4 equals 4. X is 8. So then you get your x, your y, and your z. Okay. Anyway, does that make sense? Of course, I'd rather you just use your calculator. Substitution. Just practice. Okay. If you use one of these or the other one, I just punch it in, right? Edit. So we have 3 rows and 4 columns. So 1, -2, 4, 0, -1, 2, 0, 0, 1. Right, space out for some. 1, -1, 2, 4. 0, 2, 0. We're good. Back in there. Go to math operations. RBF. Back to the matrix menu. Choose your matrix you made. So we knew that x is 8, y is 0, z is -2. So we got so right here, make a little note. Plug in z into equation 2 and solve plug in y and z and find x. That's all we did. Any questions on this example? Let's go back to this section. Here, they want you to understand if it's already in row reduced echelon form, remember we said to one down the act, it's considered to be solved. So you can just pick off the answers, right? First one is x equal to 3, y equal to -7, z equal to 0. That's what this is saying, right? So it's a three-dimensional point, x, y, z. So you would write 3, comma, -7, comma, 0. So that might represent a point in space, or maybe just 3 different variables. Number 15, they want us to solve with the matrix. So first change it. So let's do it using the other configuration. Solve system using matrices or a matrix, whatever. -2x plus 6y equals to -22. X plus 2y equals -9. So first step is change this into a matrix. -2, 1, 6, 2, augmented with -22, -9. So we have, always write the dimensions so you don't forget. We have 2 rows, 3 columns. I'm trying to find. So go to second matrix 2 by 3. So that's the same as what we have now. 2 rows, 3. Enter. You got 2, 6. You have 22. 1, 2, negative. So make sure you use the negative button, subtraction button. Yep. Let's go back to the matrix menu. Let me double check. -2, 6, -22, 1, 2, negative. Back all the way down to our RDF. Percentage. All right, go back in there and solve it. So you got 1, 0, -1, 0, 1. So this matrix is equivalent to, not equal to, equivalent. 1, 0, 0, -1, and so this means that x is -1, y is Any questions on this problem?
Yeah, I have a question.
Mhm.
Can I share my screen? Because my 15 not look like that 15.
Sure. Oh, I deleted some questions here. Let me hit save.
Oh, okay.
Hit refresh. It should be gone.
I'll stop sharing.
Yeah, I had deleted before the lecture started. I did not save it.
There we go. Much better. Thank you.
All right, cool. It fixed itself.
Yeah, thank you.
The thing I wanted to mention was when you're solving this, this is something I need you to interpret. There's 3 cases. There are 3 cases. Okay, so case 1, the easiest one, is about the unique solution. So this is going to echo the ideas of the types of systems, right? So you're going to have ones down the diagonal, and then some numbers here, right? If that happens, you have your unique system. No solution. If you get a false statement in the matrix like this, let's say you have something like I'll make up some numbers this time. 3, 4, 5. See how this equation makes no sense? This is for line 3, row 3. This is telling me that 0 is equal to 5 because there's no x, y, z. if there's a variable missing and it's equal to a number, it doesn't make any sense. So if this pops up on your calculator, you should know a row of zeros equal to 5 means no solution. Okay. So make sure you're able to interpret the results on your machine or a solver online. Or if you did it by hand, you still need to interpret this. The infinite solution case happens when you have something like this. Let's say, you know what? Let's make an actual example. Let's say this is 3, 4, 0. So if you get a row of zeros like this, that means you have an infinite number of solutions, which could mean, make it more interesting. So because there's a row of zeros, then I cannot eliminate these two parts. So what you can say is that, you know what, this is going to be x equal to x plus 2z equal to 3. And y plus z equal to 4. And z is equal to z because it's not there. So what you do is put all the variables in terms of we call this a free variable. The z can range to whatever. So what you do is say, you know what, I'm going to solve for x in terms of z and y in terms of z. Okay. So as long as z, when z varies from, you know, any real number, every time it changes, you get a different system, different solution. That's it's infinite. Okay. Does that make sense? So let's do an example where this happens and we have write it in terms of another variable. In the homework, I think the last section and this section, they use the letter A. It's kind of secret. So let's do one of those so you have an example. Solve the matrix. Systems, right? Solve the matrix. With the same thing. All right, guys. And mine is definitely closer to there. Okay, so the first equation is 3x plus 3y plus 12z equal to 15. This is the last question in your homework, number 17. X plus y plus 4z equals to 5. 2x plus 5y plus 20z equals 16. Negative x plus 2y plus 8z is equal to 1. So first step, change it to a matrix, right? 3, 2, -1. 3, 1, 5, 2. 12, 4, 28. 15, 5, 16, 1. Okay. This time let's just online somewhere. So we have dimension 4 rows. 5, 4 columns. 3, 3, 12, 2, 1, 4, 5, 2, 16, 1, 2. So see how they're saying x3 is free. So this is what you're going to do. The issue that happens. So once you solve this guy, it's going to become 1, 0, 0, 3, 0, 1, 4, 2. Then you get a row of zeros and a row of zeros. Sometimes you get more than one row. Okay, so this is telling me that x3 is free. Right. There is no x4. So let's change it into a system so you can see it better. Okay, I'm just going to call it free. So let it equal a. So what they do, well, they don't change this one, but this will become y equal to 2 minus 4z, and they replace it with 2 minus 4a. So the solution for x comma y comma z would be 3 comma 2 minus 4a comma a. So they're going to write it. Personally, if I was doing it on paper, I would just leave it as z. I don't think you change it. They do. See how right here they say, if the system is dependent, which is what we have right now, an infinite solution case, dependent system, express x, y, and z in terms of the parameter a. So we have the y component equal in terms of a, z component in terms of a. X is just a single number, so it doesn't matter. Okay. So that's why they have a and b solutions for 17. It happens when you have a row of zeros, also called a dependent system. I think in the last section there was another. Yeah, right. See, this is a dependent system because they're the same equation. They're on top of each other. So you're going to end up with a row of zeros. So they let the free verb. That's why it's like this. Anyway, does that make sense? All right, so we are, let's see. So on the 15th, we can finish. We'll do 10-2 and 10-3 on the 15th. It's not too bad. Maybe a little more. So the next exam is mainly going to be exponentials and logs and then matrices. I'll double check once we get closer. You guys have any questions on chapter 9 material? You guys been working on it? Seem okay? Any questions on matrices?
Will we be able to use the calculators on the tests to do some of it?
Yeah, you can use, so I'm not going to require work for any of the matrix questions. The only thing I'm going to ask is just convert it to a matrix or stuff like that.
Oh, okay. Just like
So,
a record to get the credit.
yeah, since I'm allowing the calculator, you know, let me go ahead and open the exam. Let's see. Details. I don't know.
Looks like a lot of stock plus is on December 4.
Yeah, I extended all the homeworks, so I sent you a message about that. Okay, so the exam. No, what's that? Yeah, the only one you have to show work would be like, we haven't talked about it yet, but when you add two matrices together, subtract them, find a determinant. That's about it. Also, just use your calculator with the answer. So that will be more flexible exam. I believe it's mainly matrices because the last test had the logs, right?
You're kind of lagging, sir.
The last exam, did it have logarithms?
Yes.
So this next test is just matrices. Yeah, okay. Yeah, you don't have to show work for this exam. Just use your machine if you want. If you get it wrong, though, it can't help you. So you show your work. Right. We'll finish this stuff on Tuesday. You guys have any homework questions or any concerns?